Bismillahirrahmanirrahim. In this session, we will discuss electric circuit, section 4.3 from Hodder's education books. This is our second videos on this topic. So, in this session, this first question is, write down the equation relating potential difference and resistances in a potential divider circuit. So in a potential divider circuit is basically two resistors are connected in series, and voltage drop across the first resistor and the voltage drop across the second resistor will be considered. So here we have I current is equals to supply voltage divided by the total resistance. So the total resistance is R1 and R2, and the supply voltage is V. So the voltage across R1 is equal to V1 is equal to I into R1 is equal to I is equal to V upon R1 plus R2. Instead, in place of this I we can write this V upon R1 plus R2. So this can be written down in place of this I. So this V upon R1 plus R2. So this V is here, and this R1 upon R2 can be written down like this. So voltage across R2 is given as similarly this R1. So instead of this R2, we have this R1 upon this, and R1 plus R2 into R2. So V is equal to R2 upon R1 plus R2. So V1 upon V2, the ratio of this is V1, this is V2. If we divide this by both, we will get this value V1 upon V2 is equal to R1 upon R2. So we'll cancel each other. So this is simple. So V1 is equal to V1 upon V2 is equal to R1 upon R2, and this is potential divider. So this is R1, this is R2. Voltage drop across this R1 is V1, and voltage drop across this R2 is V2. Now question number 2, a resistor R1 is equal to 9 ohms and R2 is equal to 6 ohms are connected in series. These two resistors are connected in series and uses a potential divider. So calculate the ratio of the potential difference across the resistor. So this is we have already discussed here. That's V1 upon V2 is equal to R1 upon R2 by doing some simple derivations. So, and as a result, we have obtained this V1 upon V2 is equal to R1 upon R2. So, this way, so this is V1 upon V2, and this is R1 upon R2. So this R1 we have this 9 ohms, and R2 is this 6 ohm. So the ratio of V1 upon V2 is equal to 3 upon 2. So this is simple. If the supply voltage is 30 volt, what is the potential difference across each resistor? So V is 30 volts, and V1 is equal to V into R1 upon R2. And this is 30 volt, this is 9 ohm, this is 9 ohm, this is 6 ohms. So this is 18 volt. So similarly for V2, this is 30 volt, and this is R2, R1, this is 6 ohms. So we have this. So this is 18 volt across 9 ohms resistor, and for 6 ohms resistor we have this 12 volt. So the ratio is 3 upon 2, like this. 18 divided by 12 is this 3 upon 2. Now question, test yourself on page 219. Resistors R1 is equal to 12 ohms and R2 is equal to 36 ohms are connected in series. These two resistors are connected in series and used as a potential divider. So this is R1, this is R2, this R1 is 12 ohms and this R2 is 36 ohms, and we are using a connected in series and use as a potential divider. Draw a potential divider circuit containing a battery. So this is a battery here, and a resistor R1 and R2 in series. So this is in series. So we have drawn this circuit. This was the simple requirement. This is the part A. In part B, calculate the ratio of the potential difference across the resistor. So this is R1, this is R2, V1 upon V2 is equal to R1 upon R2 is equal to, this is 12 ohms and this is 36 ohms. So the ratio of this potential difference across the resistance is given as 12 divided by 36 is 1 over 3. If the supply voltage is 20 volt, so here we have, this is 20 volt. What is the potential difference across each resistor? So some of the voltage drop will be here and other will be here. So this is 5 volt, so this is 20 volt is here. R1 is 12 divided by 12 plus 36, so this is 5 volt on simplification. Similarly for this is 36 volt, this is 15, so 5 upon 15 is 1 over 3, and simply we have obtained this result. So this is very important. This question is very important. Supply voltage is 20 volt and the potential difference across each resistor. So this is 5 volt plus 12 volt. So 5 volt plus 12, 15 volt, 5 volt, 15 volt, and this is 20 volt. So this potential difference will appear across these two resistors, 5 volt, 15 volt. So this is simple. Identify the following component from their symbols. So this is A is thermistor, this B is a lamp, this C is a light detecting resistor, this is a cell or a battery, this is a simple resistor. Identify following component from their symbols. So this is LED, light emitting diode, this is semiconductor diode, this is a relay, this is a coil, and this is a contact, and this is variable resistor. A circuit is required to demonstrate that the resistance of a thermistor decreases when its temperature rises. So whenever temperature rises, a resistance of a thermistor decreases. Draw a circuit diagram that could be used containing a battery, a lamp, and a thermistor. So this is a variable potential divider. If a thermistor is a part of a potential divider circuit, then its resistance decreases when the external temperature rises. So the combined resistance of the two resistors then decrease, so the voltage supply remains constant, the current in the circuit will increase. If resistance increase, temperature increases, rises, then this resistance will drop, so the effective resistance will decrease. This means that the potential difference across the fixed resistor increases relative to that across the thermistor. This means that the potential difference across the fixed resistor, so this resistance, because the current will flow, more current will flow and more voltage drop will appear across this fixed resistance. So in this way, the difference can be used as to measure the temperature through this thermistor. Figure 4.316a shows a type of thermistor. This is thermistor. This is 16b shows the symbol for a thermistor in a circuit to demonstrate how the thermistors work. So this is thermistor and how it works. This is the thermistor and this is a relay. When thermistor is heated with a match, suppose we use some fire or something hot material placed in near the thermistor, the lamp lights glow. A thermistor is in series with a meter marked in Celsius can measure temperature. Used in series with a resistor, it can also provide an input signal to a switching circuit. So this can be used to switch this circuit. So the ring will bell.